A foundation is poured, the framing goes up, and finally, the roof is set in place. If you use wood, you get a traditional cabin. If you use steel and glass, you get a modern high-rise. The sequence of construction steps is completely fixed, but the final representation varies wildly based on your materials. You understand this physical process intuitively. In software architecture, isolating a fixed construction process from a final representation is a highly effective strategy called the builder pattern. Once you lock that real-world construction sequence into your head, you will start recognizing the exact same structural logic hiding in almost every mature codebase you touch. To see why we need this strategy, look at this naive approach to object creation. You end up with a monolithic class sporting a massive tangled constructor that takes dozens of parameters just to handle a few optional fields. Engineers call this the telescoping constructor anti-pattern. The moment business requirements shift, say the product team wants to add an optional middle name or a secondary shipping address, you are forced to crack open this existing working code and wire in even more parameters. Modifying working code just to support new object variants directly violates the open-closed principle. It creates a highly coupled system where a single typo in parameter order can break entirely unrelated tests. Without a disciplined boundary separating how an object is built from what the object actually is, complex objects will inevitably turn a codebase into a fragile, unscalable environment. The builder pattern relies on three specific structural roles: the product, a static nested builder, and the client. Notice how dependencies flow. The client talks directly to the builder abstraction, passing configuration step by step. Only when ready does the builder assemble and return the finished product. Let's map these roles back to our construction site. The physical actors perfectly mirror the code classes. Framing and pouring steps are your builder methods. The finished house at the end is your final product, and the site manager ordering the work is your client. Because those abstract roles are strictly isolated, you can swap in an entirely different builder to construct a glass house instead of a wooden one, without changing a single instruction from the client. Let's look at exactly how this structure takes shape in code. We start at the foundation with the product, in this case, a user class holding standard fields like name, age, and email. The critical detail here is the constructor. It is explicitly marked private. This prevents any other part of the application from instantiating a user directly, forcing strict structural discipline. To actually create the user, we introduce our core abstraction, a static nested class called userBuilder. We write setter methods for each field, but instead of returning void, every setter returns the builder instance itself using the keyword this. Returning the builder instance enables a fluent API. Finally, a dedicated build method takes all those accumulated values and safely instantiates our private user product. Now watch how the client wires it all together. We instantiate the builder, and because those setters return the instance itself, we can chain the configuration calls into a highly readable, fluid sequence before hitting build. We've moved from a tangle of hard-to-read parameters to a clear pipeline. The client states exactly what it wants. The builder collects the state, and the result is a perfectly configured, fully immutable product. By forcing the client to depend exclusively on the builder abstraction, you can introduce entirely new product variants later on with zero changes required in your underlying client logic. This chart breaks down the strict trade-offs. The immediate cost is verbosity. Maintaining separate builder classes is overkill for simple objects, but you pay that tax to gain a highly readable, fluent syntax, guaranteed valid object state, and the elimination of telescoping constructors. Deploy this pattern the moment you spot three specific signals. You have objects with many optional fields, you need them strictly immutable, and your team requires fluent APIs. It is also crucial to distinguish builder from the prototype pattern. While prototype clones a pre-existing object entirely in memory, builder constructs a brand new object from scratch, step by step. True architectural maturity is recognizing exactly when the long-term flexibility of this pattern actually outweighs its immediate complexity cost. If you retain one concept, make it this. The builder pattern is the step-by-step construction of a complex, immutable object. The process of raising the walls and dropping the roof remains identical, even if the materials yield an entirely different structure. Once you understand how to separate the blueprint from the building, you can confidently leverage this exact architecture in any professional codebase you encounter.